Hi everybody, and welcome to part 14 of the Bravo project. If you have been following the project so far, you know that we basically built all the modules in the Bravo project, and we went through building the PCBs. We reviewed the circle logics, and also we went through testing of every individual module. In this video, I would like to put together all the modules and basically have the computer all built as a single unit. And I would like to load the operating system and some programs that has been developed by Carsten Herting as part of the minimal CPU system, so that we could see that actually the computer is operational and it's working as expected. Now, loading a operating system and program is going to basically give us a couple of things. So first, obviously, we're going to test the whole system. So if the operating system and programs are running fine, that means that we built everything correctly, and it's going to be a full test for the computer. The second point is that we have been building this computer for a couple of months, and I guess it's time, just to enjoy the build a little bit by running some programs and even doing some maybe coding on the computer, or even playing some games that has been developed by Carsten. But probably the most important part here is really to understand how the software and the hardware is going to integrate, and basically see where we're going to load the software on the hardware, and what is the order of execution of the software, and so on. And just, by playing with the operating system and also with the programs, and also probably doing, some assembly on the computer, you probably would be able to figure out parts of the design for the system and how actually the system is executing those programs. So from that point on, it's really going to be more about understanding the system and exploring the programs and the code and so on. So with that, let's get started and mount all the modules one by one. So I'm going to start with the Arduino Mega Shield, but in this video, I'm not going to actually connect the Arduino Mega board. As you can see, I have detached that because we will not be using Arduino Mega in this video. I'm just going to use this board as a base because it has this riser, and basically the computer could stand on it. Now, the first module I'm going to mount here is our clock module. And as you may have noticed, we never actually used the clock module other than the video that I was actually building and testing the clock module. For the rest of the videos, we actually were using the Arduino Mega clock, and we were either doing a manual clock, or we had a for loop that was generating the clock for us. But today we're going to actually use the original clock from the project from Bravo. And in order to do that, I'm going to actually set the clock speed to the second row of the pins that we had on the clock module. So if you remember, we had a bunch of rows on the clock module, and based on which set of pins we will be connecting, we could set the clock speeds. So in this case, if we actually connect it to the first set of pins, we will be outputting the 3.68 megahertz directly from the crystal oscillator. However, when we go to the second row, we are basically dividing that by 2. So essentially, we will be running at 1.84 megahertz, and that's what would be the speed of the computer. All right, so let's set the clock to 1.84, and I'm gonna just simply mount that into our base. So for the next module, I'm gonna actually mount the UART module, and that's just gonna be simply mounting it on the previous board. So here we go. And the next module, I'm gonna mount the A/B registers and the ALU card. So let's do that. And now we are basically left with two other modules other than the LED board. So one module obviously will be our memory module, which we have the RAM and our SSD, or the let's say our flash memory, our storage there. And also we have the control logic, which has two basically SSD flash ROMs on it. Now, before mounting these modules to the build, we basically need to do some programming, or let's say do some uploading of the ROMs. So on the memory module, we have this flash memory that plays the role of the BIOS, or let's say storage. So what we're going to do, we're going to load the BIOS/operating system on this flash. And basically, if you remember from the circuit of the memory module, when you actually turn on the computer, the first address on this flash memory is actually the first address that the computer will be pointing to fetch the instruction. Therefore, whatever we put in the first memory on this chip basically will be executed at the beginning when we turn on the computer. So this actually plays the role of the BIOS, or let's say the operating system also will be on this chip. So there is a ROM, or a ROM file, basically a binary file that have been developed by Carsten, and we're gonna basically upload that to this chip. For the control logic, on the other hand, if you remember, we had two, again, flash chips here, or comparable to our EEPROM chips here, that stores our microcode. And we had basically one, the least significant byte, or most significant byte, basically, for those, if you remember from the control logic video. So we're going to actually load the LSB file on the LSB chip and the MSB file on the MSB chip. And for this video, probably I'm not actually gonna mount the LED board, because again, we are running the clock at much higher speeds, and I guess at that speed, these LEDs probably will be only flickering, so you're not gonna be probably see that much. So we're gonna skip the LED board. Now, for programming the flash memories, I'll be using the minimal flash programmer, basically kit, which again, because a lot of people who got actually the kit for the project will be using this simple minimal flash programmer to program it. So I'll be using this one. And as you know from the previous videos, you could also use the Mini Pro for programming basically this flash memories, which is essentially this device. It is a more professional way of programming flash. But again, in this video, I will be probably using the minimal flash program. All right, so before mounting these two modules, let's do the upload, and basically we're gonna program these flash memories. So I'm gonna take out the flash memory from our memory module. Got to be a little bit careful with this flash memories. All right, so and then I'm gonna just mount it on our minimal flash programmer here. And basically that's it. Now we just need to connect the USB cable. So just gonna connect the USB cable, and let's go ahead and program this one. All right, so as I mentioned, we will be uploading 3 different files to the flashes, and the first one is the rom.bin, which is basically our BIOS/operating system that we will upload to the flash chip on our memory module. And the other files are the control logic, basically microcodes that will be uploaded to the MSB and LSB ROMs. All right, and probably by now you're familiar with the prom.exe, again, a utility developed by Carsten. that could help us basically upload these files using the minimal flash programmer to these chips. So I copied all the files here. So let's go ahead, and if you just say prom exe, you see that in order to write a file, you just have to specify the file name as a parameter, followed by a -w. Another thing which is quite important here, and I have mentioned in the previous videos, is that you want to make sure that in your device manager, if you're using Windows, that the basically USB port that is connected to the minimal flash programmer is the only one which is active. So for example, on my computer, I have COM port 1 and COM port 4, and COM 4 is actually connected to a minimal flash programmer right now. However, I have COM 1 also identified by my computer. You want to make sure that you disable any other COM ports other than one that is connected to your minimal flash programmer. And the reason being is that when you run prom exe, I don't know what is the exact logic behind it, but I think it's gonna basically pick up the first COM port that is found in the system, and that causes an issue because if you have an active COM port and this is not basically the COM port connected to the flash programmer, then the program will not run essentially. So again, just disable all other COM ports and leave the one which is connected to your flash programmer. Now with that, let's go ahead and do prom exe, and then we're going to say -w, and then the file name, which is rom.bin. So as you can see, it opened COM4 for me, and now it's basically writing that file into the flash memory. And after writing, it just does a little verification. As you can see, if you saw some errors here, make sure that you want to repeat the process. Also, it just reads about 8K again from the flash and kind of does a checksum for us, which is great. It just verifies that the data is actually written into the flash. Great. All right, so I'm gonna go ahead and switch to the MSP chip on our minimal flash programmer, and I'm going to come back and program it. Alright, so let's do the MSP chip, the same thing, except that we're going to change that to CTRL underline, CTRL underline MSP.bin. Alright. Perfect. So let's go ahead and change it to the LSP chip, and we're going to repeat the same process. All right, so now that we have the LSP chip in there, so I'm going to change that to LSP.bin. All right, perfect. So we program all the flash memories, and now it's time to power up the computer. And we are going to mount these last two modules into the previous one. So and finally our memory module. So with that, we basically have everything connected, right? And the only thing that we need is actually connecting the power. So in this case, we will be basically powering up the whole computer using the USB to serial basically module here. and that's gonna basically power up the whole computer. Oops, you know what? I noticed something. If you see that here, I actually missed a pin, and that's the problem when removing and inserting those chips. You want to make sure you're not bending the pins. So I see that pin actually was bent. Gotta be a little bit patient and careful. So let's put that back in there. All right, and we could power up the computer. All right, cool. Let's go ahead and see the operating system and programs. So now that Bravo is connected to our computer through USB, I'm going to open TerraTerm here, and the first thing that I'm going to do is going into terminal, and I'm setting the terminal size to 60 by 25. I guess that's going to just give us a better view. Now we could go into fonts, and let's change that to be a little bit bigger. So I'm gonna, let's see, I guess this one with the size 26 maybe will be a good size. Well, it's a little bit out of the window, so let's readjust it. I think that's okay now. All right, so as you can see, in my case, it is actually connected to COM port 6 on my computer. That could be any other COM port. Also, you need to set up the serial port parameters. As you can see, COM 6 is selected. If you are running the computer at 1.84 megahertz, you make sure that you set the baud rate to 115,200. And that's basically, we talked about that in the UART module, because the original clock rate is going to be divided by 16, and that's going to give you basically the baud rate. And the rest of the parameters, as you can see, we have a 8-bit data. The stop bit is 2 bits. And another thing that you could do here is basically set that transmit delay here to 35 milliseconds per line. And essentially, that gives Bravo enough time to basically process a line when you type a line of code. Essentially, that's going to create a delay when you're sending multiple offline of essentially copy pasting on the console multiple lines. For each line, it creates a little delay so that the Bravo have enough time to process it. And once you did that, essentially you should see a blank screen. And at this point, you need to go ahead and hit the reset button on Bravo, the physical button that we have on the hardware. And if you hit that and you see a screen similar to this one, then that means basically that everything is working fine. If you do not see the screen, or if you see some gibberish on the screen, or some characters in it which is different than the screen, then probably something is wrong somewhere. So if you have basically built the modules and tested along the way, the way that I describe it in each video, hopefully everything should work fine at this point. But if not, then probably you have to go back and just make sure that you check all the connections. You make sure that the solderings are all good, and you have the connections, and especially when you are placing those chips and ICs, you want to make sure that no pins are bent and so on. So essentially, a working system should show you that screen. And as you can see, we kind of landed on a random basically memory address, and that is normal because the memory, when the computer started, the RAM could be actually anywhere on any address, so that's normal. However, you could change the address. So let's have a look at the capabilities of the operating system that has been developed by Carsten. This is version 1.52, but obviously in the future there may be newer versions, so you may want check Carsten's GitHub page so that you see if he has released the new versions of the operating system and so on. But if you see here, you could type M, and then you'll be presented with a menu. So I'm going to type M, and as you can see, you have a bunch of options actually
that you could use. For example, the first one says if you want to set the memory to a specific address, you're just going to type it in hex, and that's going to take you there. So if you remember from the memory module, we said that the first memory in our RAM is actually located at a hex address of 8000 or 8000. So if I type 8000, as you can see, now we are actually pointing to the first memory address or the first memory location on our RAM. So just as simple as that, you really just have to type the memory address that you want to move to. For example, if I want to jump to memory address 8005, I could just type it and I'll be there. Another interesting thing is you could actually see the content of the memory, whether you're looking at the flash or the RAM, you could do it. And by the way, you could just switch to the flash. If I, let's say, type 0000, which is the first address in our flash memory, I could just jump into flash as well. But normally we're executing programs on the RAM, so I'm going to go back to RAM. Now, one interesting thing here is that we could actually see the content of the memory. And in order to do that, you just type the first memory address and followed by the last memory address that you want to see. For example, if I want to see the content of memory addresses between 8000 and let's say 8000F, then by hitting enter, you could see what is actually right now in those specific memory addresses. And as you can see, we started from 8000 all the way to 8015. So essentially we are presented with 16 bytes here on the screen, which each of those bytes is in one of those memory addresses. Another thing that you could do is basically store a value into a specific memory address. So let's say that right now in memory address 8000 we have value of 14, and by the way, all of these values are in hex. So let's say that we want to change that hex 14 to something else. So what I could do, I could basically just type 8000 and then basically do a colon, and then you could do, let's say, AA. And with that, as you can see, the jumper or the pointer actually jumped to memory address 8001. However, if we go back and check memory address 8000, let's say we want to see them to 5. You see that now we actually have a value of AA into memory address 8000. You could also fill a range of memory using a V command. So you could type, let's say, V, and you want to basically fill the whole memory range with a specific value. So you could say, I want to do 8000 to, let's say, 8005, filled all with value, let's say, FF. So by hitting enter, now we could again check the 8000 all the way to 8000F, and as you can see, from memory address 8000 to memory address 8005, all has been filled with FF. There is another command called K, which is a copy command, where basically you could copy the content of a memory address or range of memory address to another range. And I'm not going to go through every single command here, but you could try it. Some of those commands could be useful when you're doing coding, or I don't know, we're doing assembly. So another interesting one is the I command. We're going to look at that shortly. But first we need to actually load something in the memory so that we could see it. So I'm going to come back to that I command later. You could also save the content of the memory into a file, and that's pretty cool. So let's say that because essentially here, when you have direct access to the memory addresses and you could actually manipulate the memory, you could write code right here, right? You could type your opcodes here and the values, and it's going to be saved in your memory addresses. Then what you could do, you could just do a save, and using the S command, and essentially say save from the first memory address to the last memory address, and then you specify a file name, and it's going to be saved in your current bank on the flash. And by default, the current bank is always bank number 0. However, we can change that bank if we need it, and we're going to get to that shortly. So you could save the content of specific memory addresses by specifying the beginning address and the ending address into a file. In order to load a file to the memory, you could basically use the L command, which we're going to be using it shortly. In order to delete a file from your SSD or from your flash, you could just use the Z command and specify the name file. And in order to change the bank, if you remember, we talked about that in the memory module, that we have a flash memory and we have 16 banks starting from 0 to the 15. And you could basically change the bank. So right now, we're basically, when you start the computer, we are actually at bank 0. However, if we and in bank 0 we have some files, and if you want to see the files what is in that specific bank, we could type the T command. So using the T command shows us a list of files, as you can see in our flash bank. Now in this basically output, you see that, for example, these are the name of the files that are in the flash, and basically that's the destination when you're loading this file. That's gonna basically be loaded into memory address 8000, and the size of basically the program, which is in this case it's a program called chars or characters, and we're gonna look at that shortly. But when you load it, it's going to load into memory address 8000, and it actually, the size is 14 bytes. Well, this is in hex, so if you actually convert it to decimal, it's going to be 20 bytes. Now, if you want to change the bank, we could just type N, and let's say we want to switch to bank 1. Now we are in bank 1, and here, if you actually type T, you see that we don't have any files currently in basically our flash, and as you can see, it shows that it's basically completely free, and we could go back to flash 0 by typing N0, and now if you hit T, you see that all the files are there. Now another command, which is the last command here, is the wipe command, and if you want to basically it's like, each of those flash banks are like a different drive on your computer, and you could switch between C, D, and so on. And then you could basically just format the whole bank using the wipe command, and which is started with W. You just type W, and then it's gonna wipe out the whole bank, the current bank that you're located. Obviously, we're not gonna do it because we need those programs and so on. So I hope that that simple introduction to the available commands help you. These are just by default part of the operating system, and of course you could always write your own code, come up with your own programs and commands. But for now, let's have a look at the program. So if I say T, it basically lists all the programs or files that are currently on the bank 0 of the flash. And as you can see, Carsten kindly has created a bunch of programs and examples, which are great. And this is the part that I guess I was emphasizing at the beginning of the video, that by loading this operating system in these programs, you basically would be able to see actually how each of those programs are built. You're going to have a look at the code behind those programs and kind of learn from it how he actually were able to develop these in an assembly language. Now, let's load some of those, and we get a feeling of how stuff works. So the first program is the chars. So if I want to load that into memory, I'm going to just type L and then type chars. And by hitting enter, it's going to jump to the first memory address that program actually resides on. Here, since we were already at address 8000, it basically just stayed there. But if you were, let's say, on memory address 8005, and then we just gonna type L chars, as you can see, it's going to load the program into memory, and then it's going to jump to the first address for that program. Now we could run it, and if I run this program, what it does, it basically prints all the ASCII characters on the screen one by one. As you can see, it's kind of going kind of fast, so it's kind of filling the screen pretty quick. So that's why you see that kind of moving characters all the time. But let's reset that. And by the way, after executing any program, you basically have to physically reset the computer by hitting that reset button. So I'm gonna hit that, and we're gonna come back to the first menu. Now let's load it and have a look at it and see what it is actually in there. So I'm gonna see load chars, and then right now it's gonna load that program into memory. However, the cool thing that we could do here is we could see actually the content of that memory. We kind of have a disassembly program that has again developed by Carsten. If you look at the menu, we had an I command, and I said I'm gonna come back to that. And this is basically a disassembly utility. So it means that if I want to basically see the content of that memory in assembly language, I could do just I, and I could do, let's say, 8,000 up to, let's say, 8,000. Let's do FF, a big chunk, but I guess what we need really is just the upper part, because the program is quite short. It's only about 20 bytes, as I said. So as you see, it actually converted those opcodes, which are stored in the memory, into mnemonics. And as you see the mnemonics on the screen. So the first command is actually load immediate 20. And if you want to look at this program, load immediate basically just gonna load whatever you specify as the parameter into the A register. So here we are loading a value of 20 in hex, and all the values that you specify here with the mnemonics are actually needs to be specified in hexadecimal. So 20 is I guess if we go back to the ASCII characters, which I should have it somewhere here. Yeah, so if you look at the ASCII characters, the hex value of 20 is actually equal to decimal 32, and it's representing the space character. And from that character on, everything basically is representing every value. Hex value will be representing a character that we could type on the keyboard, and it goes all the way up to 127. So let's go back there. And so it starts from the space character, and which is basically is not going to be seen on the screen because space is just empty space. But it starts. It's going to load immediate and that, and then it's going to output that on the screen. That's another mnemonic which basically just takes the content of the A register and send it basically to our UART module. And basically just do a TX on that character. And then, as you can see, we have a bunch of no ops here, and those no ops really are just to create a little delay between sending those characters. Otherwise, with the speed that we're running, we may not send all the characters correctly, meaning that basically speed of sending the characters versus speed of receiving those. Sometimes we miss a character if you don't have some no operations. But remember that Bravo does not have any buffer, so you have to sometimes use those no op operation to create a little delay. And it's essentially each of those ops, no ops are going to create some delay. And then when you have a bunch of them, it creates enough delay for the character to be printed on the screen. And then as you can see, we have another one here which calls IMC, or inc, represents increment, and that's basically an opcode that increments the value in the A register. And that means that whatever value that we have, for example, if we have value of 20, it's gonna add 1 to that 20, and that's gonna be our next character. And then we have some conditional jumping here, which basically says that if the results of or the output of our ALU is actually still positive, just going to continue, or excuse me, this is actually looking at the flag. It says if the 0 flag is still positive, just continue to 8002, meaning that you're gonna basically you're gonna increment that number and then just output it. So that means that you're gonna move on from, let's say, space character to the next character to the next character and so on. However, once we reach the value of 127, then the 0 flag will be set, and at that point we basically that condition is not gonna met, and then we're gonna move on to the next line, which is a simple jump to address. that takes us all the way back to the beginning of the program and repeat the whole process again. So essentially with this program, we're gonna send all the characters that are available into output. We basically use tx to send all of those characters, and once we reach the last character, we're gonna kind of reset to the first character and repeat the process. So that's kind of simple program. I just want to give you an idea how this thing works. And as you can see, we're still kind of waiting, and if you hit space, you can just continue seeing more and more memory spaces. However, if you want to quit, you could just say type Q on the screen, and that's going to quit basically that operation of showing the memory addresses. Now let's go back to the program. So another one is the hello, which is the hello world demo. We could just do hello, and if we run that, it's basically just gonna do continuously type hello on the screen. So let's reset that and maybe look at another program. So I'm gonna do T. So there are also some games which are quite interesting, and it's quite amazing how Carsten has been developing these games. But we're gonna load some of those. For example, you could just load Pong. And then run it, and it's a simple game essentially that you could play. Simple pawn game. It's just pretty cool, and it's quite amazing because if you look at it, it actually refreshes the whole page continuously, and that's what you see here. Sometimes you see that the text is actually flickering. That means that there's actually creating the frame one by one continuously from on top of the string to the bottom, and that's how you create frames in these games. All right, so let's go back to another interesting one, which I guess I showed most of those stuff in the introduction video for Bravo project, but I guess here it's just make more sense once you build a computer. It's I guess really fun to see what you could do and what are the capabilities. So another game is like Blocks, and you could basically just Blocks, which is kind of a version of the Tetris game, and if you run it, you could basically just play Tetris on the screen, which is again super nice and interesting. But I guess it's quite difficult to develop, in my opinion, and I'm still surprised how he was able to develop those. But again, he has done a lot of amazing job in regard to developing the operating system and also the available operations that you could do. So that's basically an opportunity for learning here that how we could actually use a simple 8-bit computer to develop quite amazing applications. I'm gonna go back to basically I need to reset that. All right, so here we go. So yeah, there are some other programs. For example, there are some programs to like a calculator program. So let's do that. Let's just run the last one as calc 64, and you could just run this. And as you can see, that's a 64-bit integer calculator. So you could do like typing numbers on the screen, and it's basically just gonna calculate them right on the screen. So for example, I guess you could do all sort of integer operations. So I guess you could do pretty much any operation here. Yeah. Anyway, so that's how it works. Now, one more thing that I want to show you guys before we move on is let's say that we want to write a program right here, and in fact we could actually directly copy paste the opcode here on the screen. So there are two ways of doing it. For example, you could type the mnemonics here. So for example, you could just say for example LDI and then specify a value, and that's going to basically apply that into that memory address. So if you go back to, let's say, memory address 8000 and do basically an 8000 to, let's say, 8005, oops, 8005, you see that the first instruction actually, which is there, is the 0e instruction, which is the LDI, which is equal to LDI. So you could actually type the mnemonic right here on the screen, and it's going to take it and convert it into opcode, and it's basically going to save it into memory. Another thing that we could do, we could actually, again, directly copy paste the opcode. So let's say for example, the hello program, if you want to actually see the opcode version of it, this is going to be something like this. Let me copy it from the other screen, and I'm going to basically just, right click and paste it. So as you can see, I started with memory address 8000, and when you specify a colon, that means that you are trying to write to the memory. And by the way, you could, type the memories and type the content of the memory and separate it by a space. That means that basically save that in memory address 8000, the next one will be 8001, and so on. So that's basically the program. And as you can see, with when we are typing and moving on in the program, we are actually moving to the next memory address and so on. So right now, we're actually at memory address 8046. So let's go back to 8000, and we're gonna just do a run. And as you can see, that's basically the hello program that I just loaded into memory address 8000, but just copy pasting it in right on the screen. So that's another way of doing it, and that's pretty much about it. So the cool thing is that you could load those programs on the screen and actually look at the code behind it. There are also very good documentation for minimal CPU system, which I highly recommend that you guys have a look at it. So in fact, there is basically a user manual that you could get it from the Carsten's GitHub page. And by the way, I'm gonna share all the files in my GitHub page for the ROMs that we loaded into flash memories, and also for the prom.exe file and everything else that I'm showing you today. So all of those will be available on the GitHub page. But again, there's a document that is actually this is kind of a little bit older. I think the newer version of this actually is out now, so you could search for it on Carsten's GitHub page, and it gives you, a very good introduction to minimal and basically Bravo, because in hardware-wise we're exactly the same. And basically that goes into details on how the system has been designed, what are the opcodes and microcodes, and what are the memory addresses, and so on. So it's pretty cool. You could use this document as a reference, and if you go down, you actually could see the instruction set for the CPU and what type of opcodes you're supporting, and so on. And another good news is that Carsten actually has developed an emulator for the system. So rather than each time you want to, let's say, develop a piece of code or something, that you could obviously use your hardware and connect it just like we're doing it here. You could also run the emulator, and the emulator is basically just a program that Carsten has been developed, and it's kind of emulating the same thing. I mean, essentially, it's a piece of software that you're running on your PC, and you would be able to kind of mimic the minimal CPU system, or in a sense, Bravo. So the idea for this video was really to show you some of the system capabilities, and kind of showing that from this point on, it will be really all about exploring the software and getting familiar with the opcode and microcode, and understand how the system actually works. Now with that, I'm gonna conclude this video. I would probably put together a couple of more videos in near future, and I still believe that there are some points I have been learning those when I was exploring the software side. So probably it's a good idea to put together a couple of videos and go through those points. I guess from that point on, you really could do a lot of discovery on yourself and start actually developing some code and so on. All right, so I hope that this video has been informative and fun for you guys, and I'll see you next time with a new video on the software side.